So let's move on to the question and then, so here, explain the warm-up on how you would try and solve it.
To solve this, you need to need to isolate x. So you got a -3 on both sides, and then you get 1. And then look, x is, oh no, the alligator is eating 1. So x is less than 1. So you do an open circle because it's not under this, and then you just go this way. I guess.
Yeah, okay. And then write an interval notation as well.
Oh yeah, interval notation is basically
Wait, you need this.
Oh yeah, I forgot about that. Oh my bad.
Negative because it's different than
Yeah,
positive.
yeah.
Yeah, make sure that you have the negative on left, positive on right. Don't know why they want to do that, but it's because I think we read from left to right. So
That's my bad. That's my bad.
okay, cool. That sounds good.
Okay, class starts soon.
Yeah. Yeah. Let's see. These are enough. They're 20 slides.
It's 9:20.
Another video about graphing.
Wait, how's band, Kyle?
Oh, it's not fun. It's not fun.
Wait, did you guys like play a game? Like have you guys been to like football games yet?
Yes. Yeah.
Was it good?
Other than that, our football team is absolute trash. Sure, yes.
Wow.
Yes, it was 41-14.
Huh?
Oh yeah, because for one of the touchdowns,
Mhm.
the opposing team pushed our team all the way back to our end goal, so that they got a touchdown. They got 2 points.
Damn.
So yeah, it was okay. And I also forgot half the things I was supposed to do. So I mean, oh well.
Okay, you're with a group of people. They probably like, many people make mistakes, you know?
Yeah, but they're like, oh, Kai, you made a mistake. SME, shame on you.
Wait,
Why you make
they
mistakes?
realize that?
Huh?
Did they actually realize that? I thought they don't realize it.
No, they say it out loud.
Oh, during the game?
Oh no, whenever like say like I mess up something, they say no. Kyle, it's not been 3 months. It's only been one month. I'm like, oh sorry. It feels like 3 months. They're like, no.
Oh, I see the hard life.
So yeah. Oh well, I mean just petty things, honestly. I mean they still kind of respect me, so it's still
Do you like marching band, or you just do it for college?
no, like even for college, it's not even worth it. I just do it for fun.
Oh, you just do it for fun?
Yeah.
Oh my God. No. You do this for fun. Oh, that's a first.
Well, I like playing my instrument, like, hanging out with friends because, after been so long stuck inside, you want to talk to people.
Oh, that's
Yeah.
true.
And like the really only way you can do that is like do school or you can do it through band. And I'm like, okay, sure, I'll do the band.
But couldn't you done clubs instead, like something else?
Yeah, I've done clubs, but most of my clubs is like individual things. You get individual competitions. So you can do like your close group of friends, but you just talk to them though. And that's about it.
Oh, I see.
Mhm.
Oh, man, it's been so stressful. School this week. Oh my God, I have like 10 homework assignments. I haven't done one of them. They all due Monday and Tuesday. What am I doing?
Same here, yeah. Yeah, probably need to get started on that anyways. Oh well. I have tomorrow.
Wait. So do you have a lot of homework? I know it's
No.
senior. You're
Yeah.
in AP, right? How much homework do you have?
I have like physics, chemistry,
What physics?
mathematics homework, and then English I have a quiz next block.
Oh my.
Hey, math also have a, oh no, physics, math, and English have a quiz next month.
It's probably everything's probably easy for you, like I've been to you know what I mean? I've been to Texas and you guys seem so smart.
Yeah, I mean,
Damn, must be nice being so smart.
no, it's not nice. Think about like, and think everyone's smart, and then then you realize, oh shoot, I'm not special. You see,
I know, but at least the work is easy. I mean, at least you get an A. I mean, if you're smart, you can get an A easily.
well, not really, because the teachers match the level of the students. So if it's harder, then the students will push harder and things like that.
That's true.
Has no one joined yet?
Edward,
Oh, Edward, hello, good morning. Usually there's someone joining early.
Mm-hmm.
Mr. Kyle, is today the last day or is it tomorrow?
It is next week. Next week is the last day.
Well, doesn't like school start next week?
Technically, school started already for me.
Same. I've been in school.
School starts in September 1st for me.
Okay.
Oh.
Well, don't worry. We'll be wrapping up this course anyways. And like the last few days is just review, so you won't be missing too much. Here's a better question. Did everything make sense on the homework last night?
The real question is, did you do the homework?
咦，不要再看了，哥哥在上课。你看的话，哥哥没办法专心上课。
对的。
要去。去那边。
I think he left.
Yeah. Okay.
I'm still here.
Oh, Edward. Oh, hi. What's up, Edward?
So are we supposed to start now?
No, we're gonna wait a few more minutes.
But doesn't class usually start at like 6:30?
Yeah.
Yes.
6:30?
Yeah. Well, right now it's still but like 5 minutes early, so we still gotta wait for a few more students. Some students like they arrive.
Well,
Yeah, do you want to get started on the warm-up then?
Let's do the warm-up, guys.
let's just wait.
I just have it up. Yeah, you can get started and then
Okay then.
if you need help with
X
the
plus 3 is let's just
Kyle, we can see the answers, Kyle.
What did you say?
We can see the answers. Waiting for responses. Are we supposed to see it?
Yes, we can see the answers. And you can basically click show responses once everyone's done, and then you can see what you guys put for the responses. Oh yeah, shoot, I need to do this first. Join this. Here's the link. Again, you can go to Pear Deck, joinpd.com, and then type those 6-digit code, or you can just click on the link.
We'll be lazy and I'm gonna type it for you and copy paste it.
I feel like there should be a way to just
Oh
have
shoot.
the link.
That's my bad.
Oh, that's fine. Well, no one can see the link or what you typed in, even if they join late, because they can't see that yet.
Oh, that's true.
Yeah. So we got to just keep doing that. Okay. Still waiting on a few students. Edward, could you join the Pear Deck?
it's loading.
Okay, cool. David, can you join the Pear Deck? Okay. Okay, we have one student. So how's everyone's day? It's been a long week for me.
It's been a long day for me. Procrastination.
Yeah. Just gonna wait for a few more students. Make sure you guys join the paddock. Again, it's up on the board. You guys can see it. I need at least a few more students to join, so we can get some more input into the lesson. Okay, sound good? And let me type the link again. Okay. Yep. For those who just joined, here's the link, and here. Since we have a sizable amount of kids now, let's start with our warm-up. So our warm-up today is about inequalities, and let's try and answer this using graphing and interval notation. Again, can you guys join the panic? Here's the link in chat. Make sure you guys click the link and try and join. Right now, we only have 4 students in the paddock. Want to try and get more so we can try and compare our answers and see which answer is correct or not. Okay, I'm still waiting on some responses for other students, so make sure you guys, if you guys can join, it would be greatly appreciated if you could join the paddock and join us, okay? Because that's the only way I can see if you need help, and if you don't do the paddock, then I can't really help you, okay? Okay, it seems like some people have already responded. So Eric, would you like to explain basically what's your method and what you did to solve this?
I'm not in pair deck. Could you
Oh,
send
you're
the
not in Pedic? Okay, I'll send you the link again. Okay. So okay, Ian, tell me when you're done, okay?
Okay.
Remember, you guys also have to answer the question in interval notation as well. So remember where we did the brackets and things like that? I want you guys to answer in that as well. Okay, seems like most of you guys are done. Eric, would you like to explain your and basically how you got your answer?
Okay. Kyle, can we move the screen so I can?
Okay, I'm finished.
Okay, thank you, Kyle. So for what I did with this one, it's like we need to isolate the x. So to isolate the x, you minus 3 on both sides. So minus 3, and you minus 3, and you get x is less than 1. And since x is less than 1, x has to be less than 1. So that must mean that every number to the left of 1 could be x. It has to be an open circle because it's not less than or equal to. And also for the integral notation, it would be this and then negative infinity, comma 1, and then another parentheses. If that makes any sense.
Yep, cool. Yeah. Does that make sense, everyone? So basically what Eric did is that he treated basically the equation like x plus 3 equals 4, and he did negative 3 on both sides, allowing him to just get x is basically greater than 1. And because it's just greater than, we use an open circle showing that 1 is not included in our answer. Rather, it's just everything that is below 1. So in the end, we get basically parentheses negative infinity to 1 with basically curly brackets. And this is our answer in interval notation. Cool? Okay, let's move on to the next slide then. Okay, so today we'll be going over plots and basically graphing them today. So if you guys have heard of linear equations or quadratic equations, these are equations that we can plot on the graph, and it shows us how the inputs and outputs of a function basically change based on how many x or y they go up or down. Okay, so here's a quote by someone saying why we came up with the graphing system, because honestly, I don't know, but this quote really explains it very well, because basically it says that mankind invented a system to cope with the fact that we are intrinsically lousy at manipulating numbers. It's called a graph. So basically, since we are so, it's hard to visualize numbers itself, we use a graph to help us visualize it. And then we'll be using these graphs to basically help us visualize quadratic equations and then polynomials as well, if you guys have heard of those terms. Okay. So basically, what are graphs? They basically help us visualize a function. And it shows what happens when you put a specific function or a number in. Okay, does that make sense? You guys have seen graphs before, right? Like a line graph, the ones that basically go up, like with stocks and things like that. Can you say that again?
I've seen that before.
Yeah. So like stocks or anything like that, you can see that it goes up or you can see that it goes down. And basically we can use functions like x plus 3 equals y or y plus x minus 3 to show basically, okay, it's going up this way or it's going down that way or it's taking a curved path up and things like that. That's pretty cool. So before we can do that, we need to first learn about the x and y axis. So you guys remember how we did like x plus 3 equals a number? This is basically the same thing, except that that number changed to y. So now instead of just x plus 3, we have now basically x plus 3 equals y. Or we can show this as y equals x plus 3. And now we basically know that, okay, so this is on the y-axis and this is on the x-axis. The x-axis is horizontal, meaning it's going left and right, while the y-axis is height, or up and down, vertically. Okay, and this ties into what we're doing next. So basically, before we can start graphing, we need to first know about coordinates. Can anyone tell me what a coordinate is, though? Does anyone know? Okay, that's fine. So here, let me explain what a coordinate is.
Isn't it like the place where something is?
Yes, a coordinate, like,
Located?
yeah, like on the GPS, your coordinate basically tells you, okay, I'm this longitude and this latitude. It pinpoints your exact location. So basically, using the x and y axis, we can pinpoint an exact location on the graph. And basically saying, say like this is our house. We can say that 3, 0 will be the location of our house. So it's very useful. These basic coordinates are very useful for pinpointing exact positions on the graph. Okay, does that make sense? Cool, okay. So remember, x goes first. X is always horizontal, while y is vertical and y goes second. So if I had something like 2, 1, this will mean that I first go 2 to the right, 1, 2. Then after that, I go up 1 to find my location. And I found that it was right here. So, okay? Cool, does that make sense? Okay, let's do another. Okay, let's do another example. So say I have like, say my school is at -2 on the x-axis and I have -4 on the y-axis. So now I go find, okay, on the x-axis, I have -2 here. So I know it's on this, basically, this area. And now on the y-axis, I see that -4 is here. So now I go on this area. And I see where these two lines meet. And basically that's where my point is. So in this case, -2, -4 is right here. And this will be where my school is. Cool. Okay. So now let's do some practice then, okay? So basically here's a graph and I have a point on the graph. I want you guys to tell me what is the coordinate of that point.
For the first number in parentheses will be the y-axis or the x-axis.
The first number is always the x-axis. X always goes first. Okay?
Okay.
Does that make sense?
Yeah.
Okay, I'll give you guys a few more minutes. Shouldn't be too long. Okay. 3, 2, 1. Okay. Let me show responses, and we have, yep, comma 4, comma 3. Yep. Okay. Yeah, it seems I've got this. So yeah, it's not that difficult. So basically, to find this coordinate and to basically determine how we write this, we first look at the x-axis and we find that, okay, it goes 1, 2, 3, 4 to the right. And then now it goes up by 1, 2, 3. So we write this as 4, comma 3. Okay? Let's do another problem. Now we have a different point. What is this coordinate? Again, you guys use the same method to solve with this. And remember, x goes first, y goes second.
I finished.
Okay. Seems like everyone's done, so let's show responses. Okay, yeah. Yep, that's right. Make sure you guys put brackets on both sides to show that it's a coordinate. If you don't put brackets both sides, I don't really know what it means. So make sure you always put brackets to show that, okay, these are grouped together. And these two groups are coordinates. And it will help us locate where things are. Okay. Seems this is pretty good. So let's move on. And now I want you guys to grab. So I want you guys to draw where 4, -4 is. Okay? Make sure you guys are directly on the point itself. Make sure you don't put it too high or too low. Make sure it's directly on the point. Oh, yeah. Okay, so Sunny, we're doing basically graphing. And basically what we're trying to do is plot points on the graph. So in this case, we have 4, -4. I want you to basically find the point that is 4 on the x-axis, which is, let me show you this axis. This is the x-axis and this is the y-axis. So make sure that whatever number is in these two, make sure they match x and y. Oh, yes, okay. I'll send you the link to the pear deck. You guys can look on Zoom or you guys can always look on the pear deck as well.
I finished with the problem.
Okay. Look at this. Okay, so now let's show some responses. Okay. Yep. Very good. Okay, that one's cut off, but yeah, you guys got this. Okay. Yep. You guys are good. So, well, once again, in this case, we have basically a graph and we go 4 to the right, 1, 2, 3, 4. And then now we have -4, which means that we go down 4. 1, 2, 3, 4. And basically right here, this is our point. Okay?
Yeah.
So now let's basically segue into our talk about functions. Has anyone here heard of a function before? Has anyone seen a function before? That's a bad question.
Yeah.
Yeah? Okay, so could you give me a function? You can come up with any function. Remember, x is the input, y is the output. You can type it in chat. It's okay if you don't know. I can give you a function right now. Okay? So basically, a function is as simple as x equals y. That's a function. Same thing as y equals x. Another function would be y equals x plus 1. Basically, whatever we put for x, we get a y. So in this case, if we put a 1 for the x, we get 2. But if we put 2 for the x, we get 3 and so on. And then we can draw this in the table like this. Basically showing that, okay, for the function y equals x plus 1, if I have a x of 1, I get 2. If I have an x of 3, I get 4. And basically, we can use these to plot points on the graph and then draw a line. And this is what we call a linear equation. Okay? So here's some practice. Say I put a 3 into x plus 2. What would I get out? And then what about a 6 or a 9? And you guys can draw a table like what I did, or you guys can just type out the answers. Quick question, can you guys see the teacher dashboard? Basically the little screen on my bottom right corner. No? Okay. What about right now? Can you guys see it?
I can see.
You can see the little screen on the bottom right corner?
Yeah.
Right now? Yes?
Yeah.
Yeah? Okay, okay. Okay. Sorry about that. I thought it was hidden for you guys, but seems like it's shared. That's
Yeah,
weird.
you share the whole entire screen.
Yes, I am sharing the whole screen, but usually sometimes when you share the screen, it only shares one thing, not the whole thing. Well, that's fine. So let me just pull up the
App you want to be.
just pull up the responses then. Okay. Okay. Yep. Yeah, okay. So let's go back. So yeah. That's basically correct, yeah. So we put 3 into x plus 2. The first thing we get is 3 plus 2 equals 5. So let's draw the table. X, Y. If I put a 3 for the x, I get back a 5. And now what about 6? What if I put a 6 in the x? Now I get 8. How about 9? I get 11. And basically with these, we can draw coordinates with them. So our first coordinate in this linear equation would be 3, 5. The next coordinate would be 6, 8. And then the third coordinate would be 9, 11. So basically this allows us to draw those, basically figure out what points are on this linear equation, and then you can plot these out and then draw a line going through all 3 of them. Okay? So here, I want you guys to complete this table. Okay, I'm still waiting on a few more responses. Okay. I'm gonna give you guys a few more minutes. And then how about this? I'll give you guys 2 more minutes, and then when we're at 7 or whatever time hits the hour. Oh, okay. Are you guys done?
Yeah, I'm done.
Yes? Okay, cool. Yeah, let's show responses then. Okay. Okay, yeah. That's good. Okay. Okay, cool. So it's high responses. So yeah, you guys got this. Okay. So basically with this equation, what we do is that we basically substitute the x or the y depending on what we have right now. So basically right now, we have a 3 for the x in this coordinate. So what we want to do is that we want to plug in 3 for x. So instead of saying y equals x plus 3, we have y equals 3 plus 1. And then we get y equals 4. So our answer for this coordinate is when x is 3, y is 4. Now, what about when y is 5? So we substitute y for 5, and we get 5 equals x plus 1. And we can solve this by subtracting 1 on both sides, and then we get 4 equals x, or x equals 4. So in this case, 4 is our second answer. Now, for the third question, we have x equals 6. So in this case, we substitute x, and we get y equals 7. Okay, does that make sense? Again, it depends on what information you have. And basically, you can always choose, basically, if you have an x value, you put in an x. If you have a y value, you put in the y. Okay, let's move on then. So now let's talk about linear graphs. So now we understand coordinates in the graphs. We can now draw linear graphs using those equations. So like I said, y equals x is one of the most simple equation graphs that you can have. Because it basically says that, okay, if x equals 1, y equals 1. If x equals 2, y equals 2. If x equals 3, y equals 3. And you can see on this graph, this makes sense because basically, yeah, x equals 1, y equals 1. So this point. Now, what if x equals 2? Oh, y equals 2. You have this point now. And so on and so forth. So can anyone tell me why this occurs though? How come do we draw a straight line instead of a curvy one? Or how come this line is going upwards? Does anyone know? Okay, I'll wait for your responses, and then once you guys are done, I'll share your responses and let's see what you guys put. Okay, I'll give you guys 30 more seconds. You guys can think about this a little bit and try and give your best guess. Oh. Okay, you're done? Cool. Is it anyone else done? Okay. Okay, cool. Let's share responses then. Oh, okay. Again, please do not put enter many times. It's annoying sometimes to scroll through down this all the way down. Yes, I know. Someone put answer many times. Don't make me have to basically ask you guys to sign in, okay? There you go. Brought it down. On screens, okay? So basically it's going from one coordinate to another coordinate. Okay. Yeah, that works. Yeah, it's a straight line, but that doesn't really explain why it goes up or why it basically travels in that direction. The line goes to the same number of points, for example, topic. Yes, yeah, because if you have a function, basically a linear line function, it always goes up based on basically if you're increasing the same amount on x and y, it would go up on a straight line. So yeah, well, for a linear graph, yes, it will always stay straight, but for like an exponential graph or a quadratic graph, you'll see graphs that will basically curve. And this is because when x increases, y increases differently. Because if we have an equation like y equals x, for every x that increased by 1, basically, we have y increased by 1. So this makes a straight line. For every x that goes down by -1, y also goes down by -1, basically. So even if you add numbers like 10 on the same side, it doesn't affect anything. The only way that you can affect this is by multiplying it by, say, like 2y equals 2x. This instead makes the graph, instead of going basically straight 45 degrees diagonally, we instead get a graph that looks sharper like this. Basically going higher more quickly because for every 1x, y increases by 2. And we'll be going over this more later in next class, and this is what we call the slope, or basically what determines how fast it goes up and how fast it goes to the side, or basically rise over run. So let me write that down for everyone. Basically rise over run, just keep that in mind, and then we'll be talking about this next class. Okay, cool. So let me stop sharing and let's go on to the, oh, yep. Oh, go back. So yeah, same thing. So basically, in this case, what happens when you have y plus 1 instead of just having y equals 1? Well, I explained it. Basically, y just becomes up by 1. So the same shape occurs, but it doesn't change. Because y increasing by 1, or basically x increased by 1, still increases y by 1. So all it does is just makes y higher by 1. Does that make sense? Sorry if I say 1 too many times, and it may be a little confusing, but here, let's test it out. Say we have x equals 0. We can plug x into the equation and we get y equals 0 plus 1, or y equals 1. So yeah, that makes sense. It's right there. Now, what do we have? X equals basically, let's say 2. Let's do 2. X equals 2. Now, for y, we can substitute this and we get y equals 3. And we can see that, yeah, it makes sense because basically x and y are increased the same amount, but y is just being moved up by 1 initially. Okay? Does my explanation make sense?
Yeah.
Okay. So you guys ready to do some practice then? Okay, cool. Let's do some practice then. So here's the first graph. I want you guys to graph y equals x minus 2. By the way, on a side note, if you guys want to draw a table first to basically see where the coordinates are and then draw the graph, you guys are fine to do that as well. I think that may be the easiest way to do this is by first drawing a table and then finding all the coordinates on the graph. And then afterwards, you guys can draw the graph.
Time is running out.
Sorry, can you say that again? I couldn't hear you.
The Zoom is almost done.
I still can't hear you. Can you talk up a little bit?
The Zoom is almost done.
Oh, you're almost done. Okay. Is it anyone else almost done? Anyone else? Okay, it's fine if you don't have it correct. I don't expect you guys to do it perfectly on the first time, so let's show responses then. So, okay. Okay, butterfly, that's cute. Okay, actually, you were very close on this graph. You were very, very close, actually. Whoever drew this graph was very, very close. I really appreciate the effort, yeah. And okay, so let's hide responses and let me explain what we do here. So, what I would do to first solve this equation is I would first make a table. And I want to test out, let's say, you know what, 3 points. So let's do like 1, -1, and 3. So let me write those out. So let's first test out -1. So when I put -1 into x minus 2, I get -3 for the y. What about 1? I get -1 because 1 minus 2 is -1. Now if I put 3, I get 1. So now let me basically draw the points on the graph. So for -3 and I get this, -1, -3. Now for the second x at 1, I get -1, 1. And then what about at 3? I get 3, 1. So now I can see that, oh, okay. So this graph basically goes this diagonal. Oh, try and line up all the points. Let me try that again. I didn't line up all the points. So make sure all the points line up. And then basically you can say that, yes, okay. So this is the diagonal. Okay, let me try this again. Start from here. And basically say that this is the diagonal that hits all 3 points. And this is the graph for this equation. Cool?
Yeah.
Okay. Does anyone have any questions? So let's try this again. You can do this again on the next equation. So now let's do y equals x plus 3. So again, you guys can first draw the table and then put the points on the graph, and then afterwards draw a line that goes through all 3 points. And this line should be straight.
And then can we continue?
So can you say that again?
Can we continue?
Oh yeah. Sorry, I'll stop the sharing to see what you guys are doing so far and how you guys are doing.
The creation of dummy trucks, tanks, aircraft, and even units, which could be photographed by high-flying German reconnaissance aircraft.
Hey, I'll give you guys 2 more minutes.
Between the real equipment for novelty and the fake ones for fortitude. In fact, some bold fake radio broadcasts intended for the Germans to intercept, which would cause
Okay, cool. So seems like you guys are done. So let me share your responses. Okay. That's cool. Okay. Don't worry, I'll go explain this as well. Okay. Okay, you're close. Let's see if anyone tried to do the table method that I did. Okay. So this was almost correct, but if you drew the table and actually wrote the table itself, you would see that that's not what happens when you add 3. Okay, yeah, okay. This person did the table, so basically, yeah, this is correct because basically when you have an x plus 3, it basically translates the graph up by 3. And you'll learn this later, but what I want you guys to do now is to use this table to basically plot out your points. So basically, whoever this person did, they first found that, okay, at x equals 0, we have 3. And then now at negative, negative 3, we have y equals 0. Cool? Okay. So let's move back into our graph here. Let me clear my drawings. Okay, Ian, you don't say that out loud. Okay, so this is what we do is that we first, okay, let's do the table again. X, Y. Let's pick 2 numbers. Any number on this X axis will work. So let's do like 2. And then let's do 4, why not? 2 and 4. So we can first plug in 2 into X, and we get 2 plus 3, and then this will get y equals 5. So we have y equals 5 on the table. Now I plug in 4 into y equals x plus 3. So when we do that, we get 7. So now let's plot this out. So we have 2, 5, and we have 4, 7. So let's first find 2, 5. 1, 2, 1, 2, 3, 4, 5. So basically right here. Now we have 7, okay? So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. Imagine this is 7 here. Okay? And then now let's draw a line through them. So you can see that basically this line is the linear equation for y equals x plus 3. And we can check this with any other number as well. We can see, okay, let's check x equals -2. So in this case, I look at this graph and I see that, okay, if x equals -2, it should be 1 right here. So this is one way you can check graphs and determine if the graph is correct or not. Yeah. Yeah, some graphs are hard, but basically you can use basically the graph itself to check. And this makes it easier. So now let's check if this line is supposed to be what it is. So we can do y equals -1 plus 1, and we get, plus 3, and we get y equals -2 plus, or basically 1. And we can see that, yes, at -2, we do get 1. And then this is our third point. Well, does that make sense? Something does that make sense? Yes, okay. Continue, yes. Actually, this is the last slide. Okay. Cool. Does that make sense, everyone? Okay. Since Eric was basically, we have a video. Let's see. Oh, we're out of time actually. You guys want to do the video first, or you guys want to just go straight to the quiz? Oh, we don't have a challenge bomb today. Yeah.
I want to do the video.
Okay. So let me pause the share. Let me pull up the video. Oh.
Grammarly can help you write quickly and
Give me a second. Let me share sound. Can you guys see this?
I just see the video screen.
Yeah, just a
Okay,
video.
this is good.
Can anyone see what's the quote?
Yeah, I can see it.
Okay, cool. Oh, it was an advertisement.
After months of travel, you've arrived at Duonia, home to the famous temple that's the destination of your pilgrimage. Entering from the northwest, you pass through the city gates and the welcome center, where you're given a map and a brochure. The map reveals that the town consists of 16 blocks, formed by 5 streets that run west to east, intersecting 5 more that run north to south. You're standing on the northernmost street facing east, with the 2 blocks containing the gate and the welcome center behind you. The temple's only entrance lies at the very southeast corner. It's not a long walk, but there's a problem. As you learn from the brochure, Duonia imposes a unique tax on all visitors, which must be paid when they arrive at their destination within the city. The tax begins at 0, increases by 2 silver for every block you walk east, and doubles for every block you walk south. However, a recent reform to make the tax fairer halves your total bill for every block you walk north and subtracts 2 silver for every block you walk west. Just passing through the gate and the welcome center means you already owe 4 silver. As a pilgrim, you carry no money and have no way of earning any. What's more, the rules of your pilgrimage forbid you from walking over any stretch of ground more than once during your journey, though you can cross your own path. Can you figure out a way to reach the temple without owing any tax or walking the same block twice in any direction?
You guys need time? You know, try and figure this out. I'll give you guys 2 minutes. Yeah, when you guys are done, tell me and I can continue the video. Okay, is anyone else done? Is everyone done? You want to move on? Okay.
Move on, please.
Okay, well, speak now or forever hold your peace. Okay, let's move on then.
You look at the map to consider your options. Walking towards the temple always increases the tax, and walking away decreases it, so it seems like you can never reach it without owing silver. But what happens when you walk around a single block? If you start out owing 4 silver and go clockwise starting east, your tax bill becomes 6, then 12, then 10, then 5. If you looped again, you'd owe 7, 14, 12, and 6. It seems that each clockwise loop leaves you owing 1 extra silver. What about a counterclockwise loop then? Starting owing 4 again and going south first, your bill changes to 8, 10, 5, and 3. Looping again, you'd owe 6, 8, 4, and 2. Each counterclockwise loop actually earns you 1 silver. That's because any tax doubled, plus 2, halved, and minus 2 always ends up 1 smaller than it started. The key here is that while the different taxes for opposite directions may seem to balance each other out, the order in which they're applied makes a huge difference. You start off owing 4 silver, so 4 counterclockwise loops would get you down to 0. Unfortunately, it's not that simple, since you can't walk the same block twice. But there's another way to reduce your bill: walking 1 large counterclockwise loop through the city. From your starting position, walk 3 blocks south. You need to leave the southernmost street clear for the final stretch, so continuing counterclockwise means going east. Walk 2 blocks to the eastern wall, and you owe a whopping 36 silver. But now you can start reducing your bill. 3 blocks north and 1 block west cuts it to 2.5. You can't go west from there. That would leave you with no way out. So you go 1 block south and the remaining 3 blocks west, leaving you with a debt of -1 silver. And since doubling a negative number still gives you a negative number, walking the 3 blocks to the south wall means the city owes you 8. Fortunately, that's exactly enough to get you through the final blocks to the temple. As you enter, you realize what you've learned from your pilgrimage. Sometimes an indirect route is the best way to reach your destination. If you enjoy our riddles, we think you'll love the mind.
Cool. Was that fun?
Yeah.
Okay.
Do today have a challenge question?
We don't. If you guys want to talk,
Bye.
I can have one next class prepared. Don't worry. We'll be building on the subject that we learned today next class, okay? Yes, Bowen. Okay. So yeah, you guys are done. I'll see you guys next week then. Okay? I'll say tomorrow.
Bye.
Yeah.
Bye.
Bye, Edward. Bye, Eric. Bye, Julia.
Bye.
Bye.